Okay. Hello. I'm President Barack Obama. First of all, give yourselves a hand. Welcome. Welcome to my home, soon not to be my home anymore. Here we are at the beautiful Oval Office in 1600 Pennsylvania Avenue. I'm President Barack Obama. And it's one thing I know. What I slip into Southern. It's one thing I know is that I'm almost out of a job here. And I was wondering if you think I should be a math teacher following my presidency.
Would work.
It would work? You can project your voice. It's okay. There's good sound in here.
It would work.
Sounds good.
Yes. I'm feeling, community organizer, senator, U.S. president,
Fire hydrant.
math teacher.
What about fire hydrant?
Fire hydrant in my retirement. It's for, hydration purposes. But until then, I'm going to hit this trigonometry thing pretty hard. And Michelle knows that... Yeah. Hey. It gets all intimate sometimes. It's like, hey. It does that. All right, so let's start with graphing sine and cosine. Welcome to Yay Math, Trigonometry, ObaMATH sequence. You ready? You down?
I'm down.
I'm down. All right, let's do this. A quick review of the unit circle because it's going to help us a lot. I'll put it actually on the side. So draw your XY axis, please. Go over here. All right. Now, if we're talking unit circle, the unit that we're talking about is a radius of 1. All right. So imagine if this is a radius of 1, what would this point be? What, comma, what?
0.
1, 0. Very good. 1, 0. Okay. And then what would this point be?
That would be
0, 1.
0, 1. That's right. You can project your voice. It's all good. Yeah. Say it loud. What's this? As the board wobbles on me. Go.
negative 1, 0.
Negative 1, 0. Bravo. And finally.
Then 0, negative 1.
0, negative 1. Bravo. Okay. With regards to the unit circle, maybe you recall that every point on the unit circle, okay, is cosine of the angle, comma, sine of the angle. Every point on the unit circle is cosine of the angle, sine of the angle. So if we're at this particular, if we're at the x-axis, and we haven't rotated at all yet, how many degrees is this?
180.
0, 0. So yeah, as a quick review, this is 0 degrees. You can call it out. 0,
90.
90. Very good. Call it out.
180.
180. This one's hard.
350.
2.
4, not 2,
2.
60?
Well, do you agree it's 180 plus 90?
Yeah.
Yeah, so
Okay.
then
270.
270 is correct. Followed by all the way around full
360.
360. Very nice. Now let's do it in radians real quick. Okay. So this is 0. We'll put it in 90 degrees as well. Does anyone recall how many radians, let's say, is half a revolution?
Is it 2 radians?
Okay, almost. Well,
3?
2.
Is it 3?
What if I told, I will give you this. I'll give you this. Because you're actually all on the right.
Until I get it.
2 pi equals 360 degrees. All right, that's the reminder.
So it's 1 pi?
It is. So this is 0. This would be pi. All right, this would be pi over here. We'll put pi down, which is 180 degrees.
So what is 1 quarter revolution?
Good job. You tell me.
0.5 pi?
Very good. Pi over 2. Half pi. We'll put it down. Pi over 2.
Heck, you're on a roll.
And what would be 3/4 of a revolution? It's like
0.75 pi?
Yeah.
no, 0.75 pi is less than pi. It'll be over here.
1.5.
1.5.
Yeah,
1.5. You think about it, this is 0. This is half a pi. This is a pi. This is 1.5 pi. 3/4 of a revolution. That's like Bernie Sanders. Yes, sir. We need a political revolution. I need to work on my Sanders. Well, I got plenty of time in my unemployment days coming up. Yeah, so that's 3/4 of a revolution, not an entire revolution. And what would this be? It's on the board.
A full 2 pi.
2 pi. Very good. Okay, now we're going to show you how to work with this in order to graph any function you want. It's pretty awesome. So if you look closely here, we agree how many degrees is this?
0.
0 degrees. So this point, or this value here, this x value, is cosine of the angle. What was the angle again?
0.
0. So what is cosine of 0?
0.
0.
1.
1.
Oh, 1. Yeah.
What is sine of 0?
0.
0. Very good. We'll go over here to pi over 2. What is the cosine of pi over 2, or the cosine of 90? It is. What is the sine of pi over 2?
1.
Very nice.
Oh, 1 pi.
Is it 1?
1. 1. Again, cosine of pi over 2, cosine of the angle is?
0.
0.
Sine of the angle is?
1.
1. So that's there. So let's do one more, and then we're actually going to graph this stuff. What is the cosine of pi?
Negative
-1.
1.
And if you put in the calculator, you'll confirm that. Cosine of pi. Make sure you're in radian mode. This is radians. Radian mode. I got plenty of modes. And this is degrees.
It says domain error.
I actually.
Yeah, go to radians. Hit
Actually,
mode,
How to go to mode?
and then go to.
Oh, found it. And then
So I'm going to do cosine of pi.
Yeah.
Yeah, so you want to leave your calculator in radians when you're in radian mode and things like that. Okay, so now let's talk about y equals sine of x. Now we're going to hit the graph. Let's go with xy chart over here. All right. And I'm going to pick all major points of interest here. You'll see what I mean. You're going to catch on. I know you will. Separate this. And we'll put in 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, we'll do this for sine. All right. So, tell me, constituents, fellow citizens. Yes, sir, folks. I love that word, folks. Settle down now.
Countrymen.
Yeah, countrymen.
Roman.
Maybe one day I'll grow into that one. All right. What is the sine of 0 degrees or 0 radians? You don't need the calc. You don't need the
Zero.
calc.
Zero.
It's 0. It's right here. This is, again, cosine of the
that makes
angle
sense.
is here.
Yeah.
Sine of the angle is here. So put it down 0, okay?
Yeah.
What is the sine of pi over 2?
1.
1, correct. Cosine of the angle, sine of the angle. In fact, I'm going to box this. This is critical. There you go.
Yeah.
So we're going to put that down as 1. Any questions so far? Any
No.
questions? You all right?
Pretty good.
Okay. What is the sine of pi when x is pi?
0.
It is. What is the sine of 3 pi over 2?
Negative 1.
Negative 1. Chillin'.
Woo.
And then we're back to 2 pi.
0.
0 again. Right. Now we can do our graph.
Sweet.
Hook it up with. I
It's like binary.
What do you mean?
0, 1.
Yes, it's a very binary appearance. You're right, except with the negatives. You're right. Just zeros and ones.
Whoa, why is that so long?
Oh, you'll see why. Yeah, you'll see why. So let's put down pretty much what I want you to start to think about is that for graphing trig functions, start to think of 5 points of interest. Those 5 points are beginning and end. That would help. Middle and quarters. You'll see what I mean. So let's put down here the end is 2 pi. Let's put middle is pi. Quarter way, pi over 2. And 3 pi over 2. Look, I definitely acknowledge that this can be very complex first time. But I believe in the process.
Yeah.
Trust. Okay, let's put these points in, and you're gonna get it. 0, 0, we have a 1 here. We have negative 1 here. Okay, once you get that graph down, we have 0, 0. We have pi over 2 comma 1, up. Pi 0, middle. 3 pi over 2,
Whoa.
negative 1, low. 2 pi 0.
That's crazy.
Yes.
Whoa.
Do you have the curve in you? think. Okay, let's go. I'm gonna do a little like.
Your hips definitely lie.
Yeah, they're not trustworthy hips. So I'll take that as a compliment. There you go. So here's your graph for sine of x. Okay, you notice you're gonna get the curve in there, right? And what's interesting is that you'll recognize probably that it's going to go on and continue that way. Okay? And it would continue down this way and curve. All right? So does it make sense that from 0 to 2 pi, the graph is unique, and then following 2 pi, it would repeat again? Does that make sense to you? Because like at 2 pi again, it would go back over here, and this would be 5 pi over 2. Just like 2 pi plus another 2.5 pi would be the next one. So it would just continue like that, which is why we say the period, which means period equals 2 pi. And this is, I guess, the amount before which the graph repeats. That's a good way to look at it. The amount before which the graph repeats. It's like it goes to 2 pi, and then after 2 pi, it'll repeat itself. So that's sine. Any questions about sine? All right. Now that you reckon, yes, please.
What about tangent?
We're going to do that next.
That's next?
Yeah, we'll do that another one.
Okay.
Yeah, we'll do cosine this one, and then we'll stop this particular. We'll leave the unit circle. I'll take down this.
So sine and cosine, they both mix together, but tangent's a whole other...
Tangent's a little different. Yeah, yeah,
Totally.
totally. Yeah, but the sine and cosine, right, have a very strong similarity because you have cosine and sine right here in unit circle. Does that make sense? Cosine and sine are right here looking at us.
Yeah.
So we can answer every single question about cosine. Let's try it. Y equals cosine of x. Starting with, oh, I should erase the other ones. Man, you know, I'm a rookie at this job, you know. I'm a rookie.
I've been doing it 8 years.
Gotta figure, no, at the teaching thing. You know, literally, I've been doing the teaching thing for 11 years, so that's kind of, there you go. Thought I was being fancy-pantsy. 0. That's what we say, Chicago. It's the name of my favorite pizza restaurant. Joe, meet me at the Fancy Pantsy. We can do a little samba. Bump, bump, bump. All right.
So for this graph, do we also make it long?
Yes, ma'am. We do. We do that. And you'll see it looks very similar, but there's a little contrast. Okay. Based on the unit circle on cosine of 0. What is the cosine of 0, please?
1.
1. There it is.
I am
Cosine of 0 is 1. Bop. What is, over here, pi over 2? What is the cosine of pi over 2?
0.
0. Over here, pi.
The
What
negative
is
1.
cosine of pi?
Negative 1.
Negative 1. What is the cosine of 3 pi over 2?
1.
No.
0.
Cosine sine 0. You got
I was
it.
ahead of myself.
You got it.
I'm so sorry.
And now, cosine of
Now it's 1.
2 pi is 1, yes.
So, oh no. Okay, that makes sense.
You know, when I was a kid, my dad would call this cosine.
When I was a young whippersnapper.
Yeah, so let's put these down. Blending my character and my real persona. It's confusing. Must happen all the time in politics. Pi over 2. We got 3 pi over 2. Right, you'll notice it's the same increments, including 0. 5 points of interest. Beginning and end, middle, and quarters. Beginning and middle, and quarters. We go up to 1, down to negative 1. And then plot some points and curve it up. Curve it up.
You also sing?
That's career number 10. I
I've just been
so
attacked by the
in
word.
love with you.
How convenient you're in the White House.
Thank you.
That's it. Yeah, that's been known to bust in a little Al Green sometimes, but don't ask me to do it again.
Behind the scenes in the White House, we'd just be busting rhymes. So
Oh yeah.
Daniel busting rhymes.
So
So this is, I'm going to use the term now. This is 1 period of cosine. One period. What do you think the period of cosine would be? Remind me what period means?
It's the amount before which the graph repeats.
Very good. It's the amount before which the graph repeats. Do you agree that we're starting here at 1?
Yeah.
We go down. The graph isn't repeating itself yet. It comes back up to 1,
Yeah.
and then it would go down again.
Yeah.
So this is one period
Okay.
So
of cosine.
It'd go to whatever was after 2 pi, then skip whatever was after that.
Right. So what would be the next value after 2 pi? Do you agree if it's another pi over 2?
Yeah.
Yeah.
What's that value?
That would be.
5.5.
5 pi over 2.
5 pi over 2.
Right.
And then what would be after 5 pi over 2?
Then it would just be 3 pi.
It would be
correct?
3 pi. Very nice.
And
It
then
would.
it hit 3 pi, the dot. It would hit 3 pi if it keeps going. It
Yeah.
skipped 5.
So here, this is 5 pi
over 2.
5 pi over 2. It hits.
Oh no,
0.
then it hits 5 pi over 2 and skips
And
3
then-
pi.
No, and then we'll go down here.
Skip 3. It wouldn't hit.
This is 3 pi over here.
But it wouldn't hit it on the line.
No, it would not.
No, but it would hit
What
it.
is the cosine of 3 pi?
It is
-1.
-1.
-1. Do you agree? Look up here. Really important because you're going to love this stuff. It's going to help you. Every point on the unit circle is cosine of that angle.
Yeah.
Sine of that angle. So the angle in this case is pi.
Yeah.
Or 3 pi.
Yeah.
Because it's like we could go pi. And then 2 pi from there. A full revolution from there. We'll even demonstrate it. This is 0. This is pi. Do you agree 2 pi is 360 degrees?
Oh, yeah.
So let's go 2 pi from here, which is 360 degrees from
Yeah.
here. That'll be 2 pi in addition to the pi that we already went.
Yeah.
2 pi plus pi is 3 pi. So it's just like it's coterminal. That's the
Okay.
same location. So that would be -1. That's why we're down here.
Okay, yeah.
Okay.
Repeats.
So this is, the period of cosine, again, is 2 pi.
Right.
So a lot of pi.
It's a lot of pi.
So
Thanksgiving season.
So the period just equals
That was a good.
2 pi each.
For sine and cosine, the
Oh.
period are 2 pi.
Okay.
Bravo. For sine and cosine, before it repeats. Before it repeats.
That was a good line. Thanksgiving season.
Yes,
That's
yes.
a good improv.
Yes, sir. Okay, so that's all I wanted to do. Give yourselves a hand for ObaMATH. Got my curve on, my sine curve. Hello, I'm President Barack Obama. In any approaching election season, it is of the utmost importance to vote. Your vote directly shapes the future of our nation. Simply Google how to register to vote for details in your area. I'm Barack Obama, and I approve this message.